trigonometric functions. We're trying to understand the graph of these functions. First, sine x. Sine x. Now this is your complete line. This is your y-axis. This is your x-axis. This is 0. This is pi by 2. This is pi. This is 3 pi by 2. And this is 2 pi. Similarly, this is here minus pi by 2. This is your pi minus pi. This is your minus 3 pi by 2. And this is your 2 pi minus 2 pi. Now, this lies between minus 1. This is the line minus y equal to minus 1. This is the line y equal to plus 1. Let me write y equal to plus 1 and y equal to minus 1. At sine 0, it is 0. At pi by 2, it is 1. At minus pi by 2, it is minus 1. So, this will go like this. And at pi, it is again 0. So, this is the way it will go. So, this is the way it will go till here and then it will come back here. This is the graph of sine x and nothing more is there in this. So sine x lies between plus 1 and minus 1. There is no use writing plus in the front of plus. So mod sine x is always less than 1 and greater than 0. This is greater than equal to 0 because we are taking the mod value. Now the domain of this function is domain is complete R, the complete real line, but the range lies between minus 1, closed interval minus 1 and plus 1. Every value between plus 1 and minus 1. This is the range. The next is the cos function. We are going to use the cos function next one. Second is the cos function. Yes, it is the cos function. Cos x. We are taking y equal to cos x now. And now we are going to draw the same thing again. This is your x-axis. This is your 0. This is your pi by 2. This is your pi. This is your 3 pi by 2. This is again your 2 pi. And this is your minus pi by 2. And this is your pi. This is your minus pi. Then this is your minus 3 pi by 2. And this is your minus 2 pi. Again, it is also between y equal to minus 1 and y equal to plus 1. Now you see at 0 it is 1, at pi by 2 it is 0, at cos pi it is minus 1, and again this is 0, and this way the cos graph goes. This is the way cos graph goes. This is the way the cos graph goes. Wait a minute. Yes. 3 pi by 2. I made a little mistake in this graph. Wait, let me draw this little part clearly. Yes, from here it will go to 0, here minus 1, 0 and 1 here at this point. This is the way the cos graph is. Cos x also lies between plus 1, between plus 1 and minus 1. And mod cos x is been greater than 0 and less than equal to 1. Remember these points, very, very important, as I told you for the sign. The domain in this case is R, and the range again is your from minus 1 closed interval plus 1, anything between minus 1 and plus 1, as you can see. Now the next graph is tan graph. We will take the tan graph. The next is the tan graph we will take. Wait a minute. Yes. Tan graph. Third is our y equal to tan x. Tan x. Now see. Now this is your x-axis, y-axis. Then this is your 0. This is your pi by 2. This is your pi. And this is your 3 pi by 2. I'll draw till here only. That will be sufficient. Then here it will be minus pi by 2. Then this will be minus pi, and this will be minus 3 pi by 2. At tan pi by 2 gives you infinity, tan 90 gives you infinity, tan 3 pi by 2 gives you infinity. So we will draw dotted lines here at these portions. We will draw dotted lines because we cannot come to these places. In these places, we will draw dotted lines. Now tan 0 is 0. So the graph goes like this. The graph goes somewhat like this. This way. Similarly, for this, it is this way. Similarly, for this, it is this way. This way, the tan graph behaves. Why is, see, this dotted line becomes an asymptote for this curve. This dotted line becomes an asymptote for this curve. This dotted line becomes an asymptote for this curve. Similarly, this dotted line becomes an asymptote for this curve. This dotted line becomes an asymptote for this curve. This dotted line becomes an asymptote for this curve. Asymptote for a curve means that it is going to touch the curve. This line is going to touch this curve at infinity. That means they are going to run parallel, means they will never touch. That's the main point here. And the range of this, the domain of this graph, and then we will talk about the range. Domain of the graph is domain. See, we have to leave these points, odd multiples of pi by 2. This one, this one, this one, all odd multiples of pi by 2. So in the domain out of the real line, we will remove on those points. We will remove 2n plus 1 pi by 2, the odd points. We will remove all where n belongs to an integer. Where this n belongs, this small little n belongs to integers. They come from integer values, right? And this is not minus, this is, we are removing those points. Don't consider it to be this minus this. This is, we are subtracting from this set of R, we are subtracting these points. Therefore, you plus pi by 2, minus pi by 2, 3 pi by 2, 5 pi by 2, minus 3 pi by 2, minus 5 pi by 2, and so on and so forth. And the range is, see, the range is completely R. The range is completely R because it is going to minus infinity and is going to plus infinity, going to minus infinity, going to plus infinity. Let me draw this way, going to plus infinity, going to minus infinity. Therefore, complete R, that is minus infinity to infinity. This is the graph of tan. Cosec x. Now we're going to draw the graph of cosec x. Now see very carefully. I'll draw first because cosec x is nothing upon 1 upon sine x. Keep this thing in your mind. Now let's draw the graph. This is your x-axis. This is your y-axis. This is 0. This is pi by 2. This is pi. This is 3 pi by 2. And this is your 2 pi. Similarly, here it is minus pi by 2, minus pi, minus 3 pi by 2, and minus 2 pi. Now, you know the graph of sine x already. You have to draw this line of sine x for sine x. First, draw sine x. Then it will be easier for you to understand cosec x. Sine x is like this. It goes like this. It comes like this. And it goes like this. It comes like this. Goes like this and comes like this. Now, this is your sine x graph. Now, the point is how to draw this cosec graph. Now, the problem is sine x will be 0 at 0, at pi, at 2 pi, at 3 pi, and all that. So, let us draw these lines on these pi. One line here, one line here, one line here, one line at, sorry, not pi by 2, sorry, not this, not this, not this, not at pi by 2, but at pi, minus pi and minus 2 pi. You draw these lines. Now see, at 0, sine 0 will be infinity, and at sine pi it will be again, sine pi will be 0. 1 upon 0 is infinity. See, at x0, sine 1 upon x would go to infinity. Similarly, at x equal to pi, 1 upon sine pi would also go to infinity. Keep this thing in your mind. Now let's draw this graph. Now here it is. Let's draw this graph. Here it is. Your at 0 it is becoming infinity, and at pi by 2 it will be 1. This is the first one. This line is going to behave like asymptote. This line is going to behave like asymptote. Now at minus pi by 2, it will be here, minus 1, and it will turn in this manner. Wait. It will turn in this manner. Similarly, at minus 3 pi by, plus 3 pi by 2, it will be in this manner, and at this, so minus 3 by 2, it will be plus 1, so it will turn like this. This yellow colors are the graph of cosec x. This yellow color is the graph of cosec x, and the domain and range of cosec x, we are going to write down the domain and range of cosec x. See, from the domain, you will remove the point pi, plus pi, minus pi, 2 pi, minus 2 pi, 3 pi, minus 3 pi. So let me write domain in this color only. Domain for this graph is from the real line. From the real line, you will remove the points n pi where n belongs to z. This is the way it is. All plus pi, minus pi, and see, this graph does not have this. This is the line y equal to 1 and y equal to minus 1. So the range of this graph, the range is, see, this much portion is not never in this range. This much portion. See, the yellow color is not in this part. The yellow color is not here. The yellow color is not here. So the range is from the real line, you will remove the interval minus 1 to 1, the complete interval. That's why, because this is not here. This is not included here. Now we will draw the graph for your sec x. Let us see. Now we are going to draw the graph for sec x. Wait a minute. Now for sec x, this is our fifth one. Sec x means, let's write it here. Sec x means 1 upon cos x, and at x equal to pi by 2, this 1 upon cos x, cos pi by 2 becomes infinity. At x is equal to 3 pi by 2, 3 pi by 2, 1 upon cos 3 pi by 2 tends to infinity. Let us draw the cos graph now. Let us draw the cos graph. This is our 0, pi, pi by 2, pi, then your 2 pi, 3 pi by 2, sorry, 3 pi by 2 and 2 pi. Here it is minus pi by 2, minus pi, minus 3 pi by 2, and you have minus 2 pi. Let me draw it somewhere here. Just a minute. Here it is minus 2 pi, and this is the line y equal to minus 1, and this is the line y equal to plus 1, y equal to plus 1, y equal to minus 1. It starts this way. It goes this way. It goes this way, and it goes this way. It comes this way, the cos graph. I'm talking about the cos graph. This is the cos graph. Now, at pi by 2, 3 pi by 2, 5 pi by 2, there is a problem with the sec graph. So what I'll draw lines on this odd multiples of pi by 2. I'll draw this dotted lines. I'll draw these dotted lines on this point. Now, see one thing. At cos 0, it is 1. And cos pi by 2, it is infinity. So the first line will be this type. Now here it will be this type. Here it will be this type. Now see, it is not anywhere between see, here it is not anywhere between. So the domain is, I will have to remove this pi by 2's. So let's scroll this a little bit. Wait, yes, yes, yes. Now the domain of this graph, let me write in yellow only. Domain is R, from where this odd multiples are removed, this odd. So domain is R minus, wait, minus 2n plus 1, 2n plus 1, pi by 2, pi by 2 such that n belongs to z, the integers. And the range is, of course, you can guess now, this portion is not there. The range is r minus open closed interval minus 1 to 1. Closed interval minus 1 to 1. So this is the graph of sec. Now we have to go for the graph of cot. Now see, think this is the sixth one. Wait, let me use this color. Sixth one. Now this is your cot x, y equal to cot x. Cot x. Now see, cot x means 1 upon tan x. Now there is a problem at x equal to 0 because 1 upon tan x would go to infinity. At x equal to pi, tan x would go to infinity. But at pi by 2, it will be, don't confuse, at x, pi by 2, tan pi by 2 is infinity and sec pi by 2 is 1 upon tan pi by 2. So this is 1 upon infinity and 0. So no problem in this. At odd multiples, there is a problem at even multiples. This is a pi, 0, pi, 2 pi, 3 pi. So I have made you understand why not at pi by 2. I hope you understood this point and this point clearly. See, I'm repeating again. At 0, 1 upon tan 0 will become infinity. At pi, 1 upon tan pi, that will be 1 upon 0 will be infinity. At x pi by 2, tan pi by 2 is infinity, but sec pi by 2 is 1 upon tan pi by 2. So you have 1 upon infinity is equal to 0. So there is no problem at x equal to pi by 2. Now let's draw the line, draw the graph. The graph is like this. You have your 0. This is your pi by 2. This is your pi. This is your 3 pi by 2. And this is your 2 pi. Similarly, here you have minus pi by 2. You have minus pi, minus 3 pi by 2. Let me remove this now. Wait a minute. Let me remove this now to get some space. Now, let me remove this and wait. Yes. Now, this is your minus 3 pi by 2 and this is your minus 2 pi. Minus 2 pi. Now, 0, there is no problem. The problem is that the problem is at 0, at pi, at this pi, at 2 pi and minus 2 pi. So, now the thing will be like this. This graph will come just opposite to the tan graph. This is exactly the graph that is needed here. Okay, now from the domain part, the domain that is the real, from the real line, I will remove this pi, 2 pi. So I'll remove n pi such that n belongs to z integers, and the range is your this r, the complete r. You can see the complete r is going to plus infinity and going to minus infinity. It's going to plus infinity and it's going to minus infinity, going to plus infinity, going to minus infinity, going to plus infinity and going to minus infinity. See, I have, this is these all are periodic functions. That's why these things are repeated everywhere. You have seen that the repetition is always there. So this being periodic, you need to consider any point you may take between minus pi to 0, or you may take between 0 to pi. I have done it for the whole interval because this is a periodic graph. All of these are periodic graph, therefore the things are getting repeated. But you may select any one interval, let us say between 0 to pi, or minus 3 pi, or from minus pi to 0, or you can take choose like this, from minus pi by 2 to 3 pi by 2, plus pi by 2 to 3 pi by 2, and minus pi by 2 to minus 3 pi by 2. This is the way you can select. Inverse trigonometric function. A function will have an inverse if and only if it is bijective. That means it is 1 1 and on 2. 1 1 and on 2. 1 1 money means injective and onto means surjective. Either you say this way, a function will be inverse if and only it is 1 1 and onto, or you can say a function will have an inverse if it is injective and surjective. Injective means 1 1, onto means surjective. This is the point. Now, see, basically, you know, sine x, you basically know sine 0 is 0. Sine pi is also 0. For different value of x, you are getting same value of y. So this is not 1 1. कहने का मतलब ये है साइन जीरो पे भी जीरो मिल रहा है, साइन पाई पे भी जीरो मिल रहा है, अलग अलग वैल्यू ऑफ एक्स के लिए सेम वैल्यू ऑफ वाई मिल रहा है. सो दिस इज नॉट 1 1. तो इसको 1 1 बनाना पड़ेगा. वी हैव टू मेक इट 1 1. So how to make it? We will chop the interval. We'll cut the whole interval of this. We'll take only the we will only take from minus pi by 2 to plus pi by 2. See how this happens. This happens. You see, basically, let me draw the graph for you. Yes, let's draw the graph of sine x. See, this is minus pi by 2. This is minus pi by 2. This is 0, and this is pi by 2. Now, in this is my y equal to minus 1 and this is my y equal to plus 1. Now see from here, this graph goes like this. This is the sine x graph. The domain of sine x now will become the domain. The domain of this sine x will become minus pi by 2 to pi by 2. And its range is going to become minus 1 to 1. Now, in this case, now this function will become 1, 1 and on 2. And the inverse function of this will be sine inverse x. Try to understand one thing here, very, very important. And I'm telling this for those people who didn't have their maths in class 11th and 12th. Yes. Sine inverse does not, see, sine, let me write it down for you here. Let me write it down for you here. Wait. Yes. This sine inverse x does not mean 1 upon sine x. Do not write this. Never possible. Sine inverse x को कभी भी ऐसे मत लिखना 1 upon sine x. ये वो चीज नहीं है, trigonometric function है. जैसे in smaller classes you wrote x inverse is 1 upon x. This is not possible in case of sine, cos, tan and all that. Trigonometric functions. So, but so 1 upon sine x is nothing but sine x whole inverse. Do not multiply the inverse. What you used to do in smaller classes, x whole minus 1, you used to write x minus 1. But not in this case. Do not write this. Let me write it here for you. Sine x whole inverse is not sine inverse x. Note this. फिर से समझते हैं. साइन इनवर्स एक्स को कभी भी 1 अपॉन साइन एक्स मत लिखना. एक्स इनवर्स जैसे तुम लोग छोटे क्लास में आप लोग छोटे क्लास में लिखते थे एक्स इनवर्स इज इक्वल टू 1 अपॉन एक्स. दैट वाज ओके बट नॉट इन केस ऑफ ट्रिग्नोमेट्रिक फंक्शंस. सो 1 अपॉन साइन एक्स इज साइन एक्स होल इनवर्स. लाइक स्मॉलर क्लासेस में जैसे लिखते थे एक्स इनवर्स इज एक्स होल माइनस 1 इंडिसेस मल्टीप्लाई करके. यहाँ पे इंडिसेस मल्टीप्लाई नहीं होते हैं. डू नॉट डू दिस मिस्टेक. I'm saying this for all trigonometric, inverse trigonometric function, cos inverse, tan inverse, sec inverse, cosec inverse, cot inverse. Don't do this. Keep this thing, this idea in your mind. Pause this. Understand this. I'm re-explaining this again. Sine inverse 1 is not equal to 1 upon sine x. As in smaller classes, you used to write x inverse is 1 upon x. That is not possible for trigonometric function. So 1 upon sine x is sine x whole inverse. Then do not multiply this inverse inside. Like you do in smaller classes, x whole inverse minus 1 is x inverse. This is not possible in case of, this operation is not possible in case of trigonometric function. Sin inverse x को 1 upon sin x नहीं लिखना है. जैसे छोटे क्लासेस में x इनवर्स को 1 upon x लिखते थे, ऐसे नहीं पॉसिबल है. साइन के लिए, cos के लिए, cos इनवर्स, tan इनवर्स, cot इनवर्स, sec इनवर्स, सबके लिए. तो ये जो 1 upon sin x है, 1 upon sin x is sin x whole inverse. दिस डज नॉट मीन कि तुम इस माइनस 1 को अंदर मल्टीप्लाई करके साइन इनवर्स एक्स कर दो. नॉट पॉसिबल. जैसे एल्जेब्रा में करते थे एक्स इनवर्स इज एक्स. यहाँ पे इंडिसेस से यहाँ मल्टीप्लाई करके एक्स माइनस 1, ये पॉसिबल नहीं है. बिल्कुल नहीं है. होल्ड द वीडियो, राइट दिस नोट फॉर योर सेल्फ. देन आई एम रबिंग इट नाउ फॉर यू. द होल थिंग आई एम रबिंग इट फॉर यू नाउ. Now let us see what would be the domain and range of my sine inverse. It will just interchange. It will just interchange. See, now this will be the domain of sine inverse x, the domain for sine inverse x, the domain. Now the domain will be -1 and 1, and range would be minus pi by 2 to pi by 2. This will now be the range for this sine inverse x. So if I want to draw sine inverse x, this was my x-axis and this was my y-axis. Now this will remain the same. This is my x-axis and this is my y-axis. But actually now here -1 will come, here +1 will come, and here minus plus pi by 2, and here minus pi by 2. Minus pi by 2 will come. So now the graph will be something like this. Something like this. Rather, if I want to draw this here, take this, I try to draw this here. This will be somewhat like this. No, wait. Let me. My drawing is not that good. Wait a minute. Wait a minute. This will touch here. Wait, this will touch here. And this will go here like this. This and this is same. This and this is same. I hope now you understood how it is going. I've separated it for you. देखो जो पहले पाई -π/2 था एक्स एक्सिस में, अब वो बन जाएगा -1 1, और जो पहले यहाँ पे 1 और -1 था, ये वाला लाइन, एक मिनट, ये वाला लाइन जो -1 का लाइन था, वो अब ये +1 और -1 यहाँ आ जाएगा. दिस इज द वे साइन इनवर्स इज, साइन इनवर्स ग्राफ. नाउ लेट्स कम टू cos inverse graph. Now let's come to cos inverse graph. Now let's take the second one, cos inverse x. cos inverse x, cos x का ग्राफ कैसे था? हम लोग लेंगे सिर्फ 0 और पाई के बीच में. सो लेट अस ड्रॉ द ग्राफ. इसका डोमेन हम क्या कर देंगे? cos x का डोमेन, पहले हम cos x के डोमेन को छोटा करेंगे. वी विल फर्स्ट chop the domain of cos x. Cos x domain was completely r. Now I will take only now I will take 0 to pi. 0 to pi, and in this case my range is my -1 to 1. Now my cos inverse x, let's draw the cross graph. This is 0, pi by 2, and this is my pi, and this is my x-axis, this is my y-axis. At 0 it is 1, at pi by 2 it is, at 0 it is 1, at pi by 2 it is 0, and at pi it is again -1, like this it is. This is the line y equal to 1. This is the line y equal to -1. And this is my pi. Now I'll do is that for cos inverse, my domain, cos inverse x, my domain now will become domain will now become -1 and 1, and my range will become 0 to pi, 0 to pi. Let's try to plot it. Let's try to plot it. Let me drag it. Let me take a little bit more space. Yes, let me keep this graph. Now you see, this graph is somewhat like this. See, this is your y-axis, this is my x-axis, this is my 0, this is my pi by 2, this is my pi by 2, and this is my pi, right? And this is my -1, and this is my +1. This is my +1. Here it is, +1, +1. At pi it is -1, start from here. At pi by 2 it is 0 here, and at 0 it is 1. So my graph would be coming like this. So on this, if I want to draw this graph, it will be from, say, this is pi will be somewhere on the top. It will be, let me take a different color somewhere. Let me rub this much portion. Oh, my whole y-axis went away. This is my y-axis. Pi will be somewhere here, and pi by 2 would be somewhere here. somewhere here, and I try to draw this graph here, this one, it will be something like this sort, this sort, this sort. This is that. This is that. Now, the next is tan inverse graph. The next is tan inverse graph. The next is tan inverse graph. You will need these graphs to understand how the limit, continuity, and differentiability exist in these graphs or not. For example, I'll talk about here only. Wait a minute. I'll talk about here. Now they may ask whether the limit of cosec inverse exists at pi by 2. Yes, you will say it's undoubtedly exists on the right hand side and the left hand side. The limit exists, is continuous graph here. Now there is only one single tangent is even differentiable. Cos inverse x is even differentiable by looking at the graph. That's why we'll understand the utility of graph once we start the chapter of limit and continuity. It will be very, very easy. Now the third one is, wait, third one is y is, we have tan x. Now in case of tan x, your domain, it was C. You will now take tan x, for this domain, you will take the domain of tan x as uh, open interval. You will take domain of tan x as open interval. Uh, Wait a minute, let me write it down. You will take the domain of tan x as minus pi by 2 to pi by 2, and your range was completely R. This was the domain and range of tan x. Now, in case of tan inverse x, now your domain would be, in case of, you just invert everything, your domain would be now R, and your range would be minus pi by 2 to pi by 2. This would be your range. This would be your range. Now see the graph of tan x. The graph of tan x is, this is minus pi by 2, this is 0, and this is pi by 2. This is your x-axis, this is your y-axis, and I drew lines like this, and it was somewhat like this. It was going like this. Now, in case of tan inverse x, you need to just draw the same thing here. Now, this will be your y equal to pi by 2, and this will be your y equal to minus pi by 2, and now your domain is R, so you will come from here and you will be bounded. See, the tan inverse x is bounded between minus pi by 2 to pi by 2. It cannot cross this. It is a bounded function, and the limit exists everywhere. It is continuous, it is differentiable, everything. This is the graph of tan inverse x. So basically you are inverting the whole thing. That is the thing. Now the fourth one is cot inverse x. We will talk about cot inverse x. Before that, we will draw the graph of cot x. Now the fourth one is cot inverse x. Cot inverse x. Now, this is very important. Cot inverse x. Cot inverse x is, see, cot x. The graph for cot x. Graph for the domain that I'll take for cot inverse. Sorry. Cot, in what was the domain for cot? Domain for cot was Now I will change the domain for cot inverse x. I'll take the domain to be 0 to pi, 0 to pi, because cot x has a problem at 0 and pi. That's the main thing, because what is 1 upon tan x, I told you earlier. You can check that cot x video in the in the earlier part. Now the range of cot x was complete R. Now cot inverse x will have domain as R, and your range would be 0 to pi. 0 to pi open interval. Neither 0 neither pi will come. See, the cot graph was This was your 0. This was your pi by 2. And this was your pi. Cot x means 1 upon tan x. There was a problem at 0 and a problem at pi. So the graph went like this. Graph went like this of cot x. For cot inverse x, things will just change. This is the x-axis. This is the y-axis. This is your y equal to 0. X-axis means y equal to 0. And you will draw a line y equal to pi somewhere here. Y equal to pi somewhere here. And your graph would be something like this. Something like this. It will be, again, it will be crossing here. And this is the point of pi by 2. This is the point of pi by 2. So this is the way it will grow like this. So again, it is a bounded. This cot inverse x is also a bounded function, continuous, differentiable, whatever. For cosec inverse graph, we had our domain and range here. Now see, I have to make, this is not one function, not at all. So I have to make this a one function. In order to make this a one function, I have to cut this interval. Now see how we'll cut it. I will chop it from here, this line. I will chop it from here and I will erase the rest. Now see what you will see. Now my domain would be, not this, but my domain would be from minus pi by 2, from minus pi by 2, this minus pi by 2, I will include minus pi by 2. I will include plus pi by 2, from which I will remove this 0, because here the function is going to, infinity. Here the function is going to infinity. You can see here the function is going to infinity, this part and this part. That means I will subtract, I will remove. This is not subtraction, this is removing the point 0. And my range now will become, see, my range will now become, see, what can you see? From this your r, still this part is not here. In order to make, now this much part won't be there. Wait a minute, this much part won't be there. So my range would be still minus 1 to 1, but now it is completely one function. This is my one function now, from which I have this removed this 1 and minus 1, the complete interval. This complete interval, sorry, yes, this complete interval has been removed. Now, in order to draw this cos inverse function, see what I did. मैंने करा क्या है, ये पूरा फंक्शन था जो मैंने पहले बनाया था. अब मैंने इसको इस रेड लाइन से और रेड लाइन से चॉप कर दिया. चॉप करने का मतलब क्या है कि अब ये 1 1 बन गया. क्यों? अब मेरे पास सिर्फ इंटरवल है माइनस पाई बाई 2 और पाई बाई 2, और जीरो मैंने हटा दिया क्योंकि जीरो के तरफ, ये जीरो के तरफ जो एरो है, रेड एरो, वहां पे इंफिनिटी बन रहा है, और ऊपर ये जीरो की तरफ रेड एरो पे इंफिनिटी बन रहा है. तो इसीलिए मैंने जीरो को यहाँ से मैंने रिमूव कर दिया. अब क्या है, इसका रेंज तो वही रहेगा क्योंकि इसमें 1 और माइनस 1 नहीं आएगा. इस मैं कॉसेक्स की बात कर रहा हूँ, इसको मैं 1 1 कर रहा हूँ, 1 1 ऑन 2 कर रहा हूँ. अब देखो बात क्या है. Now, the thing is this, I want to find cosec inverse. अब मेरे पास cos inverse तो आ चुका है, cosec आ चुका है, cosec inverse चाहिए मुझे. मैंने अब इसको चॉप करके, ये रेड लाइन से चॉप करके इसको मैंने 1 1 बना दिया. Using this red lines, I have chopped this whole graph, and so that I have made this cosec inverse 1 1 and onto function. Now I will draw the graph for your cosec inverse. Now I'll draw the graph for cosec inverse here. I'll draw the graph for cosec inverse here. You can see the graph for cosec inverse x. Now the domain would be, your r2, from which minus 1 and 1 would be removed, and your range would now be minus pi by 2 to pi by 2, from which I will remove 0 point. Point 0 I will remove. So my sec graph would be, now see, this is my x-axis as usual. This is my y-axis as usual. Now this is my line y equal to pi by 2. This is my line y equal to minus pi by 2. Now the thing is this. Now this is, see, this interval. This is my plus 1 line. This is my plus 1. X equal to this point is 1 comma 0. Well, sorry, not 1 comma 0. Sorry, this point is 1 comma 0. Sorry, this point is 1 comma 0. This point is this line. If I draw here, this is my 0 0. and this line is my -1. This is -1 comma 0. So now what I have, this is my x equal to 1 and this is my x equal to -1. This is the portion. The graph won't be here. The graph won't be here. यहाँ पे ग्राफ नहीं बनेगा. इसका ग्राफ जो बनेगा, it will be something like this. See, it will be, this is my x-axis. Yes. See, in this case, there will be this one. From x -1, it will go to this side, and this from it will go towards pi by this from minus pi by 2 it will go to 0. This is the y equal to 0 line. Yes, now y equal to 0 line, and from here it will also go to 0 side this way. This will be the movement of my graph. This will be my cosec inverse graph. Now let us see the sec inverse graph. Let us see the sec inverse graph. I've copied the sec here. I've copied the sec here, you can see. Now what I'll do is that I'll again do the same chopping of this. What I'll do is that I will take from 0 to pi. I'll take from 0 to pi. See, 0 to pi if I take this line. Fine. I take this line. I chop this function here. I take this much portion here going down. I take this much portion going up. Now my interval will be my domain. In order to make this, my domain would be, see, this whole thing I'll rub off. My domain would be exactly, and from which I'll I'll remove 0 to pi, this much portion. 0 to pi, and I'll remove pi by 2. I'll remove pi by 2. Now this much portion of the graph I'll take, and I'll try to draw your sec inverse. I saw this sec inverse graph, and we just did this chopping of the domain. We did the chopping of the domain. Now we are going to construct the sec inverse graph. So in case of sec inverse, everything will just interchange. Wait a minute. Sec inverse x will have a domain as r, from which your -1 and 2 1 will be this will be removed. Sorry. Yes, you -1 will come. This will be removed. Let me do one correction here. This will be open, not closed, but open. Let me do this correction here. It will be open interval. This. Now, see, my range would be, in this case, my range would be range. Let me take more space. Now you remember this graph. Let me take the space. Now this range would be from 0 to pi, closed interval 0 to pi, to, from which minus pi by 2 would be removed. Now see, if I try to draw this graph, wait a minute. Now what I'll have is this. See, this is my y-axis, this is my x-axis, right? This is my y equal to pi by 2. This line is my y equal to pi by 2. This line is y equal to, and this line is y equal to pi. This line is y equal to pi, and this line is y equal to 0. Now everything has to be from which this line will not, the graph will not touch this line, because this point has been removed. Now you see it for x equal to, this is your y-axis, this is your x equal to 1, this is your x equal to 1. Similarly, this is your x equal to -1, this is your x equal to -1. So now your graph would be, see, it will go from, this is this portion of the graph I'm talking about, this portion of the graph. This is this, from which is going from this is coming from, this is the this portion I'm talking about. This portion would go here on this side, and this portion, or the other portion, would come in this side. This is the sec inverse graph. Now this function is discontinuous at all points between 1 and -1. The limit does not exist. Differentiability does not exist in this region. Nothing exists. So from 1, suppose I ask you whether there is a limit at 1 for this graph, you will say limit 1 plus exists, but 1 minus does not exist. Later on we will talk about all this limit and functions, limit, continuity. At that time, limit of a function and continuity of a function, at that time things will be more clear. Right now, just I'm saying for some sort of example. That's all.